My name's Courtney. I have my master's in soil science. I love to start out talking about soil health with just giving the definition of soil health. So, soil health is a continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. And so, in the past, a lot of folks have focused on thinking about soil in terms of thinking about mostly the chemical and physical properties of soil. So, thinking about the nutrients, the pH, texture, and structure. And thinking about the biological aspect of soil is within the spectrum of thinking about soil science. It's a fairly new concept. And so, really, incorporating soil health into your gardening is kind of just recognizing that soil is a dynamic living ecosystem all on its own. And really, we like to think of it as almost you are a livestock farmer and you are farming, helping to take care of and farm the livestock that are within your soil. So, life in the soil is extremely numerous and extremely diverse. Um, Life in the soil consists of all matter of little critters, ranging from teeny tiny bacteria all the way up to animals like gophers, which we might not like to see in our garden as much. But really, the way I think it's useful to think about soil organisms and how soil functions is kind of like a transfer of energy, right? So, the plants are photosynthesizing, they're capturing that solar energy from the sun, and then the plant roots are using that carbon to build their bodies and to create fruits and vegetables. But they're also sending about 30% of that energy down into the soil through their roots. And this energy, this carbon that they're excreting through their roots, which we call root exudates, is the beginning of the feeding of that life in our soil. So a lot of our smaller organisms are feeding off of that carbon that the plants are pumping into the soil. And then if a bacteria is feeding off that energy and a protozoa comes along and eats that bacteria, then all of the nutrients that was in that bacteria become available to the plants. So the soil food web is extremely important for many different things, including nutrient cycling. A couple of other jobs of soil organisms are to form soil aggregates, decompose plant residues, form beneficial relationships with plants. Y'all might have heard of mycorrhizal fungi and their relationship with plants, and then also to create humus and organic matter. I just love this picture. So this is a relationship of a conifer, a young conifer with a mycorrhizal fungi. I just think that's so fascinating. And fungi really have, so they create this partnership and they, with their long fungal bodies, they're able to go and seek out nutrients and water in the soil that the plant roots might not be able to reach and bring it back to the plant in return or in exchange for those sugars, that carbon that the plant is excreting. Okay, and then so if our soil is healthy, if we're taking care of the soil organisms, our soil is going to be able to perform these all of these extremely important functions that we see on the screen. So the ability to store water, which is incredibly important. This is the reason why you can go away for the weekend on a camping trip and your garden isn't shriveled and dead when you get back because the soil is able to store water for when plants need it later on or when plant roots need it. It's a habitat for organisms, of course, supports our production of crop and animals, which supports our human health. It literally is the structure that we walk on, cycles nutrients and water, and stores carbon. I'm mostly going to talk about soil health in this presentation, but I think it's really important to talk about some of the soil physical properties so that we can differentiate those from soil health and also understand how these properties affect soil health and affect the organisms in the soil. So this is our ideal composition of soil. So you can see that soil is really only about half mineral component, right? So our broken down rocks that have been worn on over millennia and mixed with other elements and turned into soil. And then 5%, this is definitely an exaggeration. You're lucky if the organic matter in your soils is 2. It's definitely a little bit higher in smaller gardens because we have so much more intensive management. These two components make up our soil solids. And then really the other 50% of soil ideally is pore space. And so that means it's just empty space. These pores, this empty space, should be filled with water or filled with air. So that's what I was saying in the last slide. If you're going away for the weekend, this is where that water is being stored, is inside these pores. And of course, soil roots need oxygen as well. So this is also where the air is stored. And if your soils don't look like this, if they're compacted, their function might be reduced because, yeah, it'll be harder for water to leach deep into the soil. It'll be harder for air to get deep in the soil. Moving on to soil texture. So, soil texture is the proportions of different size particles in the soil. We call these sand, silt, and clay. And texture is incredibly important to understand for our management. It affects how water moves through the soil. It affects the nutrients that your soil is able to hold on to. And overall, we cannot change our texture. So that's just something to keep in mind. There are many things that we can influence with our management. Texture is not one of them. So if you have a sandy soil, you can add organic matter, but if your soil is going to be primarily sandy, right? And so it'll affect all of these different things. And cation exchange capacity really just means your soil's ability to hold on to nutrients. Moving on to soil structure. Soil structure is how our texture, our sand, silt, and clay particles are arranged into aggregates. When you go out into your garden and you see, hopefully you're not seeing just fine, like little dust particles that are blowing up, but you're seeing kind of these balls of soil, if you will, like roughly shaped balls of soil. That is an aggregate. And so, yeah, there's many different types of soil structure. Our goal with soil structure, if we can, especially within the top few inches, which we have a decent amount of control over, is to have this kind of granular structure because you can see that there's a lot of pore space. So these white little particles are soil aggregates, but you can see all the black is all of those different soil pores. And so water is able to enter fairly evenly and move down in the soil. Versus if you have like a platy structure, this is generally due to compaction. And so when we have rainfall or you irrigate, water is moving a lot more laterally instead of down deep into the soil. We create aggregates by encouraging our microorganisms. Microorganisms, as they're going about their daily lives, they are eating and they're excreting wastes. And one of those wastes is this organic glue called glomalin. And that's one thing that helps stick soil particles together to create aggregates so that we can have these nice pores to let water and oxygen into our soil. So this is a decent picture of one of of soil and soil particles and then the pores. There's plenty of different sizes of pores too, right? So if you have a sandier soil, think of a beach and how big those particles are. Sand is the largest soil particle, so therefore we'll have the largest soil pores as well. And that's not necessarily a bad thing. Water infiltrates quickly, so you'll never really experience ponding, but it can move through a little bit too quickly, so you might have to irrigate more. So this is just one example of how understanding your soil texture can help with your management. So there's larger pores, macropores. This is where a lot of our oxygen is hanging out. And then the micropores, that's where a lot of the water kind of hangs out and it gets bound to the soil instead of being drained all the way through your system. These pores are really easy to spot. This picture is a good example. If you just go out and pick up an aggregate or pick up a ped, if you have a lot of earthworm activity or other microorganism activity, you should see some of these pores. This would be considered a macropore made by an earthworm. You should be seeing these pores. Take a look and think which soil, or what would I rather have my soil look like? On the left, this would probably be more of like a blocky structure. And this is a granular structure. Pretty stark difference, right? So we can see If water was entering and trying to move through this soil, it kind of really has this one main channel to move through. Versus this side, we can see that there's roots growing everywhere in every direction. There's a lot of spaces, a lot of those pores for water and air and organisms to move around in. So, this is what we are really striving for, and something that we can influence with our management. Other things that we can influence with our management or our gardening techniques is organic matter. We can also influence moisture content, of course, and temperature. Properties that we can't really change in our gardens are things like our texture, and also pH. Since it's on that logarithmic scale, it takes a lot to change your pH. It can be done, it just moves really slowly. Okay, soil testing can be really valuable so that you can get some idea of what your soil needs, what your amendments can look like, and also so that you can know what is in your soil. I've done a couple of soil tests for some folks because they were concerned about lead in their soil. And then also, if you're soil testing, you can get your soil texture done. Soil sampling every 3 to 5 years is a good call, especially because a lot of these soil practices, other than nutrients, aren't changing that quickly. Um, and I really just want to put in a plug in there for simply going out there and feeling your soil every once in a while, doing a shovel test and seeing how many worms are in your soil. That's a great indicator of soil health and will let you know that you're on the right path. I think, yeah, it's just an extremely valuable tool to simply pay attention to what you're seeing, what you're smelling. If you have water pooling, just making these visual observations. What do you get when you soil test, or what can you get when you soil test? I think for home gardeners, it's kind of a good idea to know, especially if you're trying to make your soil better. When you first begin, getting an organic matter percentage can be helpful because that's one of those things that if you are working on your soil health and trying to make your soil better, your organic matter percentage should be going up over time, slowly, but it will be going up. You can understand your pH because different plants grow differently, better or worse, in different pHs. And then macro and micronutrients to help you understand how you should be supplementing. And this is kind of a rough figure for how you can soil sample. So if this is your rectangular garden, you want to kind of just make it be random. So you want to clear off any residue on the soil surface, and then you can take about a 6-inch depth with your trowel in a couple random spots throughout your garden. And then you should put them all in a bag or a bucket and then make sure to mix that really well before you send it to the lab so that you have a homogenized sample, which will give you good results. So, we're going to move into talking about the soil health principles now. So, soil health has definitely been a buzzword for the past several years. And we have boiled down some kind of key concepts into the soil health principles. And for right now, we're going to talk about them as the 4 soil health principles. They are keeping our soils covered. We want to minimize disturbance. We want to maximize biodiversity. And we want to keep living roots in the soil as long as possible. All of these principles are associated with different practices, right? Different management. And that management can look different in all of these cases, but these kind of key principles remain the same. Beginning with the first one, so maximizing our soil cover. So this is fairly simple, right? So we just want to keep our soil covered as much as possible. You've probably seen this in nature. Nature doesn't want her soil to be bare. That's why weeds pop up and the soil tries to cover itself. So this can be done a lot of ways in our gardens. This can be done by utilizing mulches under our plants or in our rows with straw, bark, shredded leaves, wood shavings, grass clippings, any really organic material. And that if we're using these organic materials, then we are also adding organic matter to our soils and helping keep those organisms happy, right? We want to avoid plastic and dyed mulches if we can. Plastic is really, while it is extremely convenient, if the plastic is permeable, then it's all right. But we definitely want to avoid plastic that won't allow any air or water into our soil, and not only into our soil, but out of our soil. We can create an anaerobic environment within the soil, which is like if you haven't turned your compost for a while and it has a really bad stink, most likely because your pile has gone anaerobic, so without oxygen, and we want to avoid that. Um, we want to avoid rock, especially dark rock, as this can really concentrate um, basically the sunlight. It just makes things really hot. It can make the area around your plants really hot, and it's just good to avoid. Especially, obviously, you can put rock paths in, but I think it's a good practice to avoid planting rocks or keeping rocks right around the base of plants, as it can make them really hot. Okay, and then the last way, or one of the last ways that we'll discuss, is leaving plant residue on the soil unless it is diseased, of course. So maybe you top your lavender and you chuck the lavender stems just right back on the soil. Unless it's diseased, you can just leave plant residue on the soil. Organisms will slowly incorporate it and feed on that material. So this has a lot of different benefits, right? So I think a big one with this is reducing evaporation. So just slowing down the water. Sometimes when you water and then the soil looks really shiny and flat in that area, that's just because the water's hitting the soil fairly intensely, and those aggregates can break apart if they're not very strong and kind of turn into, just the individual soil particles again. So the mulch is also great for keeping those aggregates together so it doesn't blow away and result in soil erosion. Mulch is great for suppressing weeds and protecting the soil surface. You'll maintain a more constant or optimum temperature, which is great for our soil organisms. And also, a big one that I like talking about a lot is if we're leaving our soil covered, we can be increasing insect habitat over the wintertime. But of course, if you notice any pest pressure from this and you're overwintering pests and that, then you have to reevaluate that situation. Our second practice is minimizing soil disturbance. And this can be not only physical, as in tillage, but also chemical and biological disturbance. I like to think about soil health is really just, we're just trying to mimic nature. And nowhere in nature we see as destructive as of an act in soil as tillage is. And I'm not saying all tillage is bad, but we want to minimize it. So tillage is very destructive for our aggregates that our soil organisms work really hard to build. So it's breaking these aggregates apart and reducing our pore space. We kind of create that shiny, smooth soil surface, which makes it harder for seedlings to emerge and can create that surface crusting. Tilling also introduces a lot of oxygen into the system, which makes our organisms go into a little bit of a frenzy, and they can start breaking down organic matter really quickly. And then we also just want to make sure that we're not working the soil when it's wet, because that can harm our soil structure and create more compaction. So if we create walking paths through our garden, that's a really great idea, so that we're not walking all over the soil that we're going to be planting into. And this has plenty of great benefits as well. One of those being that we're really prioritizing the soil food web, and we're taking care of those, especially our fungal populations, which have those really long hyphae bodies, and tillage can really easily destroy those. And then, minimizing or maintaining our soil structure and decreasing erosion. Our third principle is keeping a living root in the soil as long as possible. And this can be done several different ways as well, with perennial plants, using different seasonality of plants like cool season plants and warm season plants. And also, if you ever decide you want to plant a cover crop, like a cover crop is a great addition to an orchard area that will help keep your soil covered and keep it in place. The big benefit of keeping a living root in the soil as long as possible is providing a continual food source for our soil organisms so they continue to cycle those nutrients for us. If they are cycling these nutrients for us and performing their duties, they will also be building soil structure and aggregation, which helps with our water infiltration and storage. If we have plants growing as long as possible, this is going to be great for pollinators. Literally, just keeping our soil covered with plants is going to help suppress weeds and create more habitat for our soil organisms. Last one we're going to talk about today is maximizing biodiversity. So, this can be done several different ways as well. Planting diverse selection of plants, making sure that you're rotating where you're putting your plants. You should always be rotating your different crops around so you're not planting them in the same area every year. Planting different functional groups of plants. So this is like trees, shrubs, forbs, all of these different functional groups have different root systems. Different plants have different root exudates. So the more diversity above ground, the more diversity below ground. And then, if possible, you can integrate animals. We talk about this a lot with our larger producers, integrating animals, but it's also possible at the smaller scale. I read a study a while ago that more diversity of plants generally equals more biomass of those plants. There's a lot of synergy that happens when we're growing a diverse amount of plants. So this will improve our nitrogen or our nutrient cycling, and all of these principles will make our soils more resilient to stress. And then I also wanted to mention that if you are integrating animals, like maybe say you, when the season's done, if you have chickens, you let your chickens into your garden over winter time. This integration of these animals, they're not only kind of scratching things around and incorporating organic matter into the soil, but they're also adding nutrients to the soil through their waste, and so you're kind of creating this mini loop in your garden with your nutrients. So it's kind of just a fun thing to do and another way to introduce nutrients and also feed your microorganisms. So when we're taking care of soil health, we are maximizing water storage. Our soil aggregation leads to better porosity, which increases our water infiltration, not only water infiltrating, but also the soil's ability to hold it. And this is great for many things, but irrigation water is not, it's not cheap, right? So we're saving valuable resources, whether that's in the form of irrigation or in the form of precipitation. Um, these pictures illustrate this really well. The power of having pore spaces and not disturbing our soil really allows water to infiltrate. And this is that kind of shiny, smooth surface that I was talking about. And so we can maximize our water storage by decreasing disturbance and also keeping our soil covered. Okay, and then by keeping plants in our soil for as long as possible, we're constantly farming that sun, if you will, and having carbon enter our soil where this is feeding our microorganisms, and they're going to be forming all of those wonderful benefits for us. Remember, you're gardening plants, you're planting tomatoes and marigolds and peas, but you're also taking care of the soil organisms underneath your feet. And they, if you do, they will be performing all of these wonderful functions and helping you out with your gardening. So, right, by following all of these principles, but especially by keeping roots in your soil and prioritizing diversity, we can make this happen. Here's some resources, different bulletins from Wazoo and Oregon and U of I that you can kind of look at to help you along on your journey with soil health.